Let's break this problem down by drawing a free body diagram right on the image. First, let's identify all the forces acting on the block. We have the applied force pulling at an angle, which is already shown. Then we have the force of gravity pulling the block straight down. Because the block is resting on a floor, there is a normal force pushing straight up against gravity. Since the block accelerates horizontally to the right, there is a kinetic friction force opposing this motion, pointing to the left along the floor. To analyze the motion, we need to break the applied force into its horizontal and vertical components. The horizontal component pulls the block forward, and the vertical component pulls it slightly upward. Now, let's look at the vertical direction. The block isn't flying into the air or sinking into the floor, so the vertical forces must balance out to zero. The upward forces are the normal force and the vertical component of the applied force, and the downward force is gravity. Next, let's find the force of kinetic friction. Friction is proportional to the normal force. Finally, we apply Newton's second law in the horizontal direction. The net force is the forward component of the applied force minus the friction force. To find the acceleration, we just divide both sides by the mass of the block. Looking at our options, this matches choice A perfectly. That is a fundamental question. We split the force because the block's motion is restricted to moving strictly horizontally along the floor, but the force is pulling at an angle. Because it's at an angle, this single pull is actually doing two different jobs at the same time. First, it is pulling the block forward. We need the horizontal component to find out exactly how much of that force is contributing to the forward acceleration. Second, it is lifting the block slightly upward. This upward lift is crucial. Because the force is lifting the block a little bit, the block doesn't press down as hard on the floor. Since friction depends on how hard the block presses against the floor, the normal force, that upward lift actually reduces the friction. By splitting the angled force into horizontal, x, and vertical, y parts, we can use Newton's laws to analyze the forward motion and the vertical balance completely separately.